Hi everyone, this is Mrs. GA, and today we are going to learn how to divide polynomials. So I have a quick warm-up for you guys, so please pause the video and give it a try, and we'll check your answers in just a few seconds. Alright, go ahead and check here. So for the first one, first you have to factor out the GCF of 3x. Then you can factor this more using the sum of two cubes formula. And then for part B, you can factor this by grouping, and you end up with x squared minus 3 times x minus 5. So there are two different ways that we're going to learn to divide polynomials. So the first one we're going to try is polynomial long division. So polynomial long division is very, very similar to just normal long division. So just as a quick recap of how it works, if you have 256 divided by 6, we put 258, we put it inside the little table, and we put the 6 on the outside. You say, how many times does 6 go into 2? Well, it doesn't, so we look at the 2 digits. How many times does 6 go into 25? It goes in 4 times. And then we multiply and put the product underneath, so here, and then we subtract, and then we bring down the next number, and then we say, we start the whole process again. How many times does 6 go into 18? 3, so then we put the number up top, then we multiply and subtract. And then if there's a number here, this would be a remainder, and if there's no remainder, it means that it's a factor because it divides in evenly. So we're going to kind of do the same process of saying how many times does this go into this, and then we multiply, we subtract, and we do it all over again after bringing the next digit down. So one thing to watch out for when you're doing polynomial long division is look at both polynomials. If there are any missing terms, make sure you use a placeholder of 0. So if you're missing the x squared term, say plus 0x squared, and it will make the long division process much, much, much easier. All right, so let's look at this first example together. We have 4x cubed plus 2x squared plus 3x plus 5. So there's no missing digits here. So that's going to go inside our little table. And then we're dividing that by x squared plus 3x plus 1. So also no missing digits, so we're ready to go. So when we do that first step of saying how many times does this go into this, we're really just going to work with the term with the largest degree. So we're going to be working with this term. And we're going to say how many times does x squared go into 4x cubed? Or another way of thinking about this, we're just doing 4x cubed divided by x squared. So if you want to do that out on the side, you can, but that gives us 4x. So we're going to put 4x on top here, and then we're going to do the process of multiplying. So this 4x, we're going to multiply it to all three terms, and we're going to line it up with these terms right here so we can subtract after. So 4x times x squared is 4x cubed, and then we have plus 12x squared plus 4x. Now this next step, we have to be really careful. We're subtracting every single term. So I really recommend putting the minus and then parentheses to kind of remind yourself that we're subtracting everything. So this first term is just 0. Here we have 2x squared minus 12x squared, so it's negative 10x squared, and then minus 1x. And then we can bring down the next digit, so plus 5. Now we're going to do it all over again. We're going to say how many times does x squared go into negative 10x squared, or really what we're doing is negative 10x squared divided by x squared, and that gives us just negative 10. I'm going to put that on top. Then I'm going to multiply negative 10 to all three terms, so negative 10x squared minus 30x minus 10, and then be careful here, we're subtracting everything. So this becomes 0. This becomes negative x plus 30x, so it becomes 29x. And then here this becomes 5 plus 10, so plus 15. And then as soon as you reach a point where the degree here is smaller than your degree here, we are done. So that means that we have a remainder. So there are a few different ways that we can write our answer here. One way that we can set up our answer is in terms of factors. So if we're dividing this polynomial by this, we're saying, okay, imagine this is one of the factors. So we can say the original polynomial, we'd say 4x cubed plus 2x squared plus 3x plus 5 equals the factor we divided by times our answer, which is 4x minus 10. And then we have our remainder, which would just be added on at the end. So this is one way to write your answer. This is a pretty useful way of thinking about it because really we do long division to check for factors when we're trying to find zeros of our polynomials. So again, this is one way you can write our answer. Another way that you might see it written is you just see the answer, so 4x minus 10, and then you have your remainder, and you put your remainder over what you're dividing by. So it would be plus 29x plus 15 over x squared plus 3x plus 1. So this is just more of the answer. This is writing your answer in terms of factors. So again, just two different ways. For our textbook, they like us to write our answer out like this. But again, depending on the textbook you're using or the context of the problem, this is also an acceptable answer. So here's the answer plus the remainder. Okay, let's try another one together. I'll go a little bit faster with this one. So this first polynomial, you'll notice that we are missing an x term. So we are going to make sure to have a placeholder there. So we have 9x to the fourth plus x cubed plus 11x squared, and I'm just going to say plus 0x minus 4. And then in this polynomial, we're also missing an x term, so I'll put a placeholder there as well. And then we're going to start our process. We're essentially doing 9x to the fourth divided by x squared. So we're going to say 9x squared. And now we're going to multiply. So we get 9x to the fourth plus 0x cubed. And I'm just going to put x cubed here so it lines up with my other x cubed term. This is more of just a placeholder. And then here we get 144x squared. And now here just be really careful because we are going to subtract every single term. So our x to the fourth terms cancel out. This is just x cubed minus 0, so it's just x cubed. And then this becomes negative 133 x squared, and then we can bring down our placeholder, and let's do it all over again. So x cubed divided by x squared is just x. Then we multiply, so we get x cubed plus 0x squared plus 16x, and we're going to subtract everything. Be careful, this is negative 16x, and then we'll bring down our last term. And then here, negative 133x squared divided by x squared is just negative 133. Then we multiply everything. So negative 133x squared. Again, we're going to have this placeholder for x. Okay, and then again, we are subtracting everything. So this becomes negative 16x, and be careful here. This is negative 4 plus 2,128. So we get to positive, so plus 2,124, and that will be our remainder. So we could write out our answer. We'll do that two different ways. So our original polynomial equals x squared plus 16 times 9x squared plus x minus 133, and then plus our remainder, so minus 16x plus 2,124. So this is like the factored version of our polynomial, or we could write it as an answer. So the answer was 9x squared plus x minus 133 plus our remainder divided by our divisor. So two different ways to write our answer. All right, so go ahead and pause the video and give this one a try. We'll check your answers in just a few moments. All right, go ahead and check your work here. Make sure that you do have that placeholder for x squared. And then again, here's the two different ways of writing your answer. So here we're writing our answer in the form of a divisor times the quotient plus the remainder, or here is just our answer with the remainder written as a fraction. Okay, so now we're going to talk about a different way that we can divide polynomials called synthetic division. The thing about synthetic division is we can only use it when we're dividing a polynomial by something in the form of x minus a. So the coefficient of x does need to be 1. It's okay if a is a fraction, it's okay if a is positive or negative, but again, it needs to only be divided by something like this. So if the degree of x is higher than 1, we can't use synthetic division. So here's how the setup of synthetic division works. You look at what you're dividing by, so this is a factor. Imagine if this was a factor of your polynomial, what the 0 would be. If the factor is x plus 5, the 0 would be negative 5. So in a little box right here, we're going to put what I call the 0. Okay. Then we're going to look at the coefficients, just the coefficients of the terms in our original polynomial, and we're going to list them here, and we're going to put 0 for any placeholder. So the coefficient of x cubed is 7, the coefficient of x squared is 0, the coefficient of x is negative 6, and then our constant is 9. And then leave a little space, and then I draw a line like this. And if you want, sometimes we even draw a little dotted line like this, because this is going to be our remainder box. So synthetic division, you start just by dropping down your first number, and then it's just a process of multiplying and adding. So you take your 0, you multiply it by this number, and you write your product here. And then you add vertically. So 0 plus negative 35 is negative 35. And then we're going to do that again. So I'm going to do negative 5 times negative 35, and I'm going to put my product here. And then I'm going to add vertically. So we get 169. And then I'm going to do it one more time. So negative 5 times 169 is negative 845. And then we add vertically and we get negative 836. So these are the coefficients in the remainder of our answer. So when we're writing our final answer, what you're going to do is look at the degree of your original problem. And we're going to drop that down 1 to write the variables for our answer, because we started with x cubed and we divided out a power of x. So this just means 7x squared minus 35x plus 169, and then this is our remainder. So our remainder is negative 836 over x plus 5. So this is one way we can write our answer, or again, we could write it out in that factored form. So we could say 7x cubed minus 6x plus 9 equals x plus 5, what we divided by our divisor, and then times our quotient, which was our result. So 7x squared minus 35x plus 169, and then we have our remainder, minus 836. So here you go. Now, what's important here, again, is to remember when you're writing your divisor, your answer, your quotient, which is your answer, you take the original degree and you drop it down by 1 because you're dividing out a 1 power of x. And then it's just decreasing in power as you go across. So x squared, x to the first, x to the 0, and the last number should always be our remainder. Sometimes it's 0, sometimes it's a value. All right, let's try another one together. So here, my factor that I'm dividing by is x minus 1/2. So that means the 0 would be positive 1/2. So it's always going to be opposite of what you see in your factor. And then let's list out our coefficients. So we have 4, 0, because we don't have our x cubed term. We do need that placeholder, or else the synthetic division won't work. The negative 3, 7, and 2. And then here we go. So drop down your first number and multiply, and then you add and you multiply, and then we add and multiply, add and multiply, and then last step is adding. So again, these are the coefficients of our quotient, and since we started with x to the 4th, this is going to have x cubed. So our answer is 4x cubed plus 2x squared minus 2x plus 6, and then our remainder is 5, so 5 over x minus 1/2, or we could write it out in that factored form. So our original polynomial, equals our divisor, x minus 1/2, times 4x cubed plus 2x squared minus 2x plus 6, and then our remainder is just 5, so we say plus 5. There you go. All right, again, please pause this video so you can give this one a try on your own, and we will check your answers in just a few seconds. Okay, go ahead and check your work here. One thing to check for is that you have that placeholder for your x squared term. And then here is our answer in that factored form with our remainder of 7. Okay, so now we're going to talk about 2 ways that we can apply this synthetic division that will be really useful for us for the rest of this unit. So the first is the factor theorem. So if you use division and the remainder is 0, then we know that what you divided by, that divisor, is a factor of the polynomial. So this is really common sense. You guys knew that if you divide into something and there's no remainder, it's a factor. So we can use synthetic division to help us really quickly check to see if something is a 0 of our polynomial. And we know that when we're graphing polynomials, finding the 0 is going to be a really important thing. So being able to check for this quickly is going to be a really important skill to form. So again, I want to see if this is a factor of this. So the 0 would be -3. I'm sorry, I just noticed a little typo. This should say 3x squared. So our coefficients are 1, 3, -4, and -12. And we're going to do our quick synthetic division. And again, if our remainder is 0, then x plus 3 is a factor. So let's give it a try. So you can see that our remainder is 0, which means that x plus 3 is a factor. And then you'll see here it says, well, if it is a factor, let's find the remaining factors. So look at what we have here. What we have left is x squared plus 0x minus 4. So this, of course, we can factor using difference of 2 squares. So we have x plus 2 times x minus 2. And again, our original factor was x plus 3. So now this is the factored form of p of x. So there you go. All right, so now I have one for you to try on your own, so please pause video and give it a try. We'll check our answers in just a few seconds. Okay, go ahead and check your work here. So when you do your synthetic division, the remainder is 0, which means that x plus 1 is a factor. And this remaining polynomial, you can factor by grouping and then difference of 2 squares. So here's your completely factored polynomial. And you could also write this as x plus 1 squared times x minus 1 times x minus 5. Just don't forget to include that original factor of x plus 1 in your final answer. All right, I have another one for you to try, so please pause the video and we'll check your answers in just a few seconds. Okay, so you can see here when you do your synthetic division, making sure you do have that placeholder for the x squared term, you do get a remainder of 6, so therefore x minus 1 is not a factor of this polynomial. All right, the last thing we're going to do today is talk about a pretty cool application of synthetic division, which is the remainder theorem. So you can actually use synthetic division to help you evaluate a polynomial. So if you have your polynomial and you want to find, I don't know, f of 3, you can use synthetic division. So you would use 3 in the box of your synthetic division, and whatever you get as the remainder in your synthetic division will actually be your answer. So oftentimes using the remainder theorem can be a lot quicker and easier than actually plugging it in and multiplying it out by hand. So definitely a cool thing to have in your toolkit. Okay, so in this first one, here's our polynomial, and we want to find p of -2. So again, we know we could find p of -2 by hand. So here's how we would do it without the remainder theorem, right? We would just do 5 times -2 cubed minus 12 times -2 squared plus 3 times -2 minus 5. And then you'd have to go through and multiply this out. And you would get -99. Or you could use synthetic division. So we can put negative 2 in our little box, and then we do 5, negative 12, 3, negative 5, and we do our quick synthetic division. And here, the remainder of our synthetic division is the answer, which you can see right here. So again, the remainder theorem is just a really kind of a cool thing that you can use as an application of synthetic division, and we can use it to help us evaluate a polynomial. And sometimes I honestly do think that this is faster than having to sit here and multiply this out. I think it also might help you avoid small mistakes. All right, last example, so please pause the video and give it a try, and we'll check in just a few seconds. All right, go ahead and check your work here. You do need to be careful that you have that 0 placeholder for your x cubed term, but here, using synthetic division and the remainder theorem, we can find that p of 3 is negative 45. Okay, so that's all for today's lesson. Thank you so much for watching.